Perfect. So good morning, good afternoon, or good evening. This is the Antrea community meeting, and today is September 13th or September 14th, according to your time zone. We'll get started in a few seconds. On the agenda for today, we have Abhishek and Lan with a proposal for multi-cluster support in Antrea. This is described in GitHub issue 2270, which I'm sharing on the Zoom chat. So, Abhishek, if that's okay for you, perhaps we can get started. I believe we're already 2 minutes into the meeting, so I'm not sure many people are going to join. Okay, so you're already sharing a screen, so go ahead.
Cool. Could you also provide sharing capabilities to LAN, or if LAN wants me to continue to present, that is also fine with me.
Yes, let me see if I have to do anything for
That's
that.
okay. I think Abhishek, you can show the doc. Yeah, I can talk after you.
I mean, Lan, are you not able to share the screen? Because I don't know, honestly, I don't know which button I have to click to give you this. I mean, I can only make you co-host. That's the only thing I can do. And if
I think that's okay. You don't have to do that. I think when Abhishek finishes the first a few parts, I can continue, and he will show the docs.
Sounds good.
Not much.
Okay, yeah. Perfect.
Sounds good to me. Okay, so maybe we'll start. Hi, everyone. Today, we would like to talk about multi-cluster integration with Antrea. The motivation behind this feature is that typically you would see users deploying the Kubernetes clusters, and they would deploy multiple clusters, and essentially for various reasons, they would deploy services in these multiple clusters, and perhaps there is also some work going on in upstream Kubernetes, specifically targeting this area. And there is a KEP available, which is called the MCS KEP, MultiCluster Service KEP, which is introducing some CRD, some resources, some ways to standardize how communication between multiple clusters may happen, and also how these services can be shared across clusters. So that is the motivation behind why we want to do multi-cluster integration with Antrea. We want to standardize some of those APIs and some of the CRD concepts with Antrea specifically for multiple clusters, which can then be a platform or like a base for other tooling to be created on top of this effort to perform more more workflows in this area. So basically we're going to look into some of the high-level use cases that we see, and these might not be the only use cases, but these are something that we've seen in the community. And then we will look at the MCS KEP that I spoke about. We'll look at what those CRDs are really, how they look like, and because they form the basis for our following CRD design. And then we will briefly, or rather not briefly, we'll take a look at our CRDs that we plan to implement for multiple clusters, and how the different clusters will interact with each other, and how do we form the registration and registration workflow for clusters to be onboarded as part of the multiple clusters set. And then once we have this multiple cluster set, how is this resource exchange going to work within this within this set of multiple clusters? So we're going to look at the resource exchange pipeline, and then we would also like to discuss some of the items that we will not be targeting in the phase 0 or the immediate couple of releases for Antrea, but but that's something that we have on our mind to work on, and Lan will help in presenting some of the portions here. So, and feel free to stop me. I want to give credit to Lan and Akshay's team who's worked on this effort. So they've helped a lot in the CRD design and the overall architecture. So yeah, so let's begin with a few high-level use cases, why this is needed and why the community is moving towards this. So one of the use cases is, when you have multiple clusters, you could have like one scenario in which the same service is being deployed in all of your clusters, or a subset of your clusters. Now the reason behind this could be multifold. It's possible that the administrator wants to have some sort of an HA support, some sort of locality wherein like services are created, which are more local to the workloads, based on geo or availability zones. And it also could be done to improve the scale of the services. So these could be some of the reasons why a user could deploy the same service in multiple clusters. When we talk about same service, what we mean is that the name and namespace of that service across these clusters is the same. So that's the basic criteria for a service sameness. Now, as we all know, that Kubernetes clusters are kind of a hard boundary, wherein the basic fundamental idea is that within the cluster, pods can access each other freely, but outside of the clusters tend to be well protected. So now, as a use case, like if you have a service which goes down in one of your cluster, all the workloads within that cluster may lose access to that service. And even if there is a similar service which is serving the same content in a different cluster, these workloads will not have that access. So that's one of the reasons why a user may do same service just to support HA. Another use case that we see is that there might be cases wherein you have some services which are common throughout different clusters. Now those services could be some public services that the organization has, some DNS services or log management, which are shared across services, which are the shared services across clusters, and they need to be accessed by multiple clusters. So here we need to enable, or the use case of the administrator is that the intercluster service consumption should be enabled. So this is another use case that we see for which people may use multiple clusters. Now, when we talk about opening up traffic across clusters, that also leaves a use case for security. So, for example, perhaps I don't want to expose all of my workloads to other clusters, even though they are mutually trusted. But still, I would want to only expose the pod or workloads which are the backends for this service, my public service or my multi-cluster service, and necessarily don't want to expose other pods within my cluster. So there is this concept of security that should also be applied, and Antrea must be able to solve that. There are a couple of use cases around security. One is consistent security. So for example, you have multiple Kubernetes clusters, and as an administrator, I want to ensure that all of my clusters that come up have some sort of a consistent behavior in terms of when the workloads start up, there is some sort of a baseline security associated with those clusters. So essentially, you want to, perhaps it's a baseline default deny, or maybe you are denying inter namespace traffic and only allowing inter namespace traffic. So those kind of baseline rules must be repeated in all Kubernetes clusters. Now, one way to do it is doing it manually, writing those policies in every cluster, or the other way is to use some APIs exposed by MultiClass by Antrea, wherein you write the policy once and it gets copied over to all your clusters. That's one use case. The other use case is, whenever you're talking about exposing traffic to multiple clusters, you're talking about security across clusters. So what we are calling as stretch security across clusters. So here you may have certain pods which should only accept traffic from other pods in other cluster, but not necessarily expose traffic to everything else. So this is basically what we mean by saying that, pods or workloads in one cluster should be able to access services in other cluster, but not other traffic. So this is like stretching your policy, not just to your own local cluster, but defining it across multiple clusters. So this is slightly different from the first previous use case. So far, any questions on the use cases, or before we move on to the design? If not, then maybe I'll hand over to Lan to continue on the design, and then I'll take over once she's done.
Okay, thanks, Abhishek. Can you have to scroll down a little bit? Yeah. Oh, the first the diagram, you may go through this part first. Where you?
Oh, you want me to go through the diagram? Okay, sure.
Yeah.
So
yeah. Sorry.
No worries. So typically, what we want to do is, like, we want to enable cluster communication across different Kubernetes clusters. Now, as part of that, we introduce two types of clusters. So there could be, so every cluster is called as a member cluster because it is part of a multi-cluster set. And then in order to facilitate the exchange of resources and manage some of these member clusters, the member clusters elect a leader. And the job of the leader cluster is to facilitate this resource exchange pipeline. And that is those kind of clusters are called leader clusters. The leader clusters would be public consumption. So this is called something called an inbound mode, wherein member clusters have the ability to reach to the leader cluster. So the leader clusters Kubernetes API should be publicly accessible by the member clusters, while the member clusters could be on-prem or wherever they can. And essentially, the communication is from the member clusters. So the MCS controller, which is called the multi-cluster controller component, is what reaches out to the Kubernetes API of the leader cluster, and they can push objects and listen to objects from the leader cluster. So this diagram pretty much kind of like shows the different kind of clusters and how they interact with each other. And then we have these MCS kept CRD, so which I briefly alluded in the beginning. This is something that is being proposed upstream, and Lan will take over from here.
Yeah. Okay.
And Lan, feel free to tell me
Abhishek.
to go up and down. Yeah, thanks.
Okay. Yeah. Abhishek just mentioned about our class set management. I feel a little bit about that. And here is a way, that when there are the Kubernetes service, usually it means locally to its own cluster. When we want to use the service from another cluster, we need a way to tell the user or the other pod how which service will be exposed and which service can be accessed by outside. So we reused the MCS cap CRDs, which is the service export and the service import CRDs. We just use the definition and the CRD in our entry multi-cluster design. And for the service export, as you see here, it's actually used to specify that which service in your cluster you'd like to expose to all clusters in the class set. And the service export, you have to create it manually in each cluster. At least for now, we require user to create manually. And in each cluster, you need to expose and tell user that this service I like to expose to other clusters, and then they can access the service. So in one cluster, the service, when you create a service export in a cluster, it's signifying that the service with the same name and in the same namespace, they will be treated like the same service in the cluster set. Okay. Abhishek, can you scroll down a little bit? Okay, thanks. So you can see here that there are the basic definition of service export and also the service export status and also the condition. We just reuse that from the MCS, the Kubernetes MCS API. So this part actually is the same as the Kubernetes MCS. And the next part is service import. You know that when we export the service, we need to import them because if we didn't do anything for that, the member class, other member cluster won't know that they can't learn that which service I can access from remote, right? So the service import is actually act just like in-class representation of a multi-class service. And usually in Kubernetes MCS definition, it's just like the it's like traditional service type, but it's a little different. In Antrea MultiCluster feature, we just use this service import type definition, but not the CRD. So you won't be able to see the CRD, this actual real CR in the member cluster. We just wrap these service imports into our resource import type, which I think Abhishek will introduce it more in later. So here you will just see those basic definition from Kubernetes MCS API. Okay, Abhishek, can you scroll down? Yeah. So for the very basically, when we want to access a multi-class service in a class set in Antrea, we will create it's just like a general service. We will use importer. We call it importer to create a multi-class service, and it's just like any ordinary Kubernetes service, and it's generally backed by an endpoint of the same name. And if usually we only create it as a class IP service because we only create this kind of service as multi-class service, and you can just use it as a local service as the same way. So you and it will be the all load balancer, the traffic load balancer will do by the local Kubernetes network interface plugin, and just like Antrea do. And this kind of class IP is also cannot be accessed by outside of the cluster. You can just think it as a general Kubernetes service. And you know that when we create a multi-class service, we need to consider that what's the endpoint behind it. And once we create a multi-class service by Antrea importer, and we need to consider what's the endpoint behind it, because this kind of service is actually a remote service, right? So the importer will create some endpoint, and with an annotation like the MultiCluster Kubernetes .io and with the service name, and the endpoint behind it, we will treat it a little different based on the members, the exposed service type. For cluster IP, actually there's some assumption for this feature for the cluster IP. And if the pod IP behind that are known outside of the cluster, then we will use those pod IP as an endpoint. So this is the basic requirement that the pod IP can be accessed outside. And then the port will be the same as the service target port. And the class IP, if it's with external IP, then you know the external is IP known outside of the cluster, then we can use it directly. And we also use the same port defined in the service. So for node port and load balancer, they actually are similar logic, but the endpoints are a little different based on their types. For the external name, well, we just treat it like Kubernetes MCS API because we are not clear about this use case, so it will be ignored. Let's take a class IP with external IP as an example. A typical access flow for a multi-class service access. You will consider that you just, let's say you want to access a remote service, then a local pod will access the multi-class service locally. Then it's actually just like a ordinary Kubernetes service, and the class IP, it's let's say the entry give the service class IP, and the class IP will be mapping to the endpoints, which we just show that above. What kind of endpoints for the class IP with external IP? Then the remote member class service and endpoint external IP will be the endpoint. So when the request, you know that the pod actually access remote service external IP. So when the traffic goes to the remote cluster, the traffic will be routed to the pod because the external IP is just you can consider it as a virtual IP, right? So the real IP, the real pod serving the service, it's actually the pod, right? So the pod will be given the service. And the traffic will eventually goes to the pod by the CNI. Yeah. Any question here? Okay, Abhishek, you can scroll down. Okay, here is about the multi-class set management. Abhishek just showed that we have a multi-class controller, and also their member cluster, their leader cluster. For class sets, it's actually a placeholder name for a group of clusters. When we want to gather a few of clusters into one class set, and we treated them like a mutual trusted and shared ownership, that their service can be shared in one class set. And when we the class, as I just said, it's just a placeholder name. We use the MultiClass Set CRD to describe multi-class sets. And member cluster defines a member cluster, just like its name. You can see here in the definition for the member cluster, it will have its own class ID. And the server means the member itself's API or the leader cluster's API. And the secret, it will use for member or leader to access the remote cluster. And the service account, it's also used by member cluster to access to leader cluster. And also there are a few other fields like the MultiClass status. We will use it to represent how the member cluster works. It's healthy, or maybe there's some error behind it. Okay. Abhishek, you can, move forward. Okay. Okay, here. Here are some other fields like we use we follow the CAP 2149. We use the class set and the class ID and the class set to describe the class set and also our Kubernetes cluster. I think it's quite simple. So we move forward to the member announce. We use member announce to declare that a member cluster configuration to leader clusters. basically a member announce will just tell the class set that, or the leader class that what's my class ID, and it will learn what's a class set ID or which class set it belongs to, right? And it will choose one of the leader cluster as its own leader, which means that member cluster will expose those service to the leader cluster. Okay. Okay, let's move forward. Here's some steps or basic configuration about the MultiClass set. In very beginning, we need to do one thing is that create or define a MultiClass set. So there are actually some manual steps we need require user to do this, or our cluster admin to do that, because in early implementation we want to do those automation, but in the future we might use the command line or operator to do this kind of thing to build up a MultiClass set. In the first, if we want to create MultiClass set in leader cluster, you know that member cluster need to access the leader cluster. So we need some access information for them, right? So we need to create a service account for each member cluster. And we also need to create or transfer those kind of service account secret to those member clusters. And in leader cluster, we need to associate those leader role to MultiClass controller's service account, so it can do those resource controller, right? This is a basic requirement, and also the member role to the each of member service account, which we just mentioned above. And in each member cluster, you know that I think Abhishek will talk a little bit more about export and import. Here we will associate the export and the import cluster roles to the MultiClass controller service account. And in each cluster, of course, we need to I mentioned above that we need a member announce to tell the class set itself about its class ID, right? So we need to to apply those unique class ID and the class set ID in each cluster. And also in leader and the member cluster, we need to make sure that all the MultiClass set definition or the resource they are sync and consistent. And okay, let's go down a little bit. Okay, here when I just mentioned how to create the MultiClass set above the basic steps, but when it's we may have a dedicated leader cluster for the whole class set, so there may sound different, but here the basic steps actually the same. The little difference is we may create those MultiClass sets, the service account, the roles in namespace, specific namespace. That's the main difference. And if we want to add a new member cluster to existing member class, existing MultiClass set, actually the major steps, just like the first part, we need to create a service account for the member cluster in each leader cluster, right? And we need to copy this kind of service account secret to the member cluster, and do similar things to make sure that the whole class set sync those new member cluster, and the new member cluster have the correct service secret, which it's created in first step. And when there are new leader cluster, it's trying to we're trying to add a new leader cluster to an existing MultiClass set. The first thing that I think the whole scenario is almost the same as the first part. The only difference is that in leader cluster, you need to create a service account for all existing member cluster and create this service account secret to those clusters. And also the same, we need to do the same thing to sync all multi-cluster set in each member cluster. And for the if anyone, any cluster trying to leave the cluster or admin remove the cluster, we just need to remove the member announcement, which remove the class ID and the class ID, and also the multi-class set CR. And in leader clusters, all the member class and the leader clusters will think about these actions to remove this cluster from the class set. Yeah. Okay. Any questions so far? I think for the MultiClass set management and MCS cap CRD, that's all from me.
Maybe take a pause and see if there are any questions so far.
Yeah.
I don't really have a question, but more like a general, a general confusion. Like all this MCS cluster proposal, it's something that it's been actively developed upstream, something that we are picking up from some upstream work which is currently suspended, or is this something that we are doing specifically for Antrea? I was looking at the cap that you referenced, and I don't know what's happening there. It seems like there is a sort of out-of-tree implementation, but you know, I don't know if we are going to reuse that implementation or if we are going to do another implementation.
Oh, we just that's a quite simple implementation. We just reuse service export. We don't want to recreate a similar definition, so just reuse this a small part into our implementation. That's all. That actually there are a lot of other stuffs we need to do in Antrea. And I believe Abhishek will show you that how our resource exchange pipeline like, and you will learn more about what Antrea multicluster do. We are not limited to the source export because in the future we may export the endpoint and the network policy, etc. So the cap 1645 is I think just a very little part.
Okay, thanks.
Yeah, to add to what Lan said, so Salvatore, this is more like the CAP 1645 is more like, you know, this is what the specification is for service export and service import, but we don't really provide an implementation. So it's more like the network policy API, right? You have the resource specification up there. Now you can implement it in a way that you want to, and then extend it using whatever CRDs that you would want to. So what we are providing is one different implementation, which will be building on top of the service export and service import CRDs, which were introduced as part of this kit.
All right, thanks. So just to finish this conversation, the controllers for this CRD will be something that will be provided by Antrea because there is not yet an upstream controller for these CRDs, right?
That's correct.
Okay, thanks.
The controllers will be provided by Antrea, and then some more.
Thanks, Abhishek and Lan. Thanks for the clarification.
So if there's no more question, we'll continue with the resource exchange pipeline. Thanks, Lan, for a wonderful presentation. So to build on what Lan just mentioned, the MCS CAP CRDs are just talking about how service resource can be exported from one Kubernetes cluster to others. And they have introduced a couple of CRDs for that purpose. What we want to also do, and that is outside of the KEP's scope in the upstream community, we also want to be able to export not just the service resources, but we would also like to export in future, network policies or Antrea native policies to be able to do the stretch network policies use cases that we spoke about in the beginning, but also endpoints and different other resources. And also we want to make sure that the way in the information is exchanged among the clusters is standardized. And to this point, we plan to introduce two new resources called resource export resource and a resource import resource. Now, as the name suggests, they are pretty much like an extension to the service export and service import resource. So the resource export resource is pretty much a wrapper around the resources that would be exported from one member cluster to another. So as mentioned, that is similar to the service export concept, except that it will be exporting this encapsulated resource to other clusters. And we will look at the pipeline diagram a little later, but this is how the CRD resource export spec looks like. Essentially, you will have like, what is the name of the resource and the namespace in which this resource is exported to, and the kind of that resource, that is, because we plan on to encapsulate more than just the services. So it could be a service, or it could be some endpoints. It could be external entities that we could use to implement engineering policies or for some other use cases. And then we also plan to do a raw resource export. Now, the reason why is that we want to do a raw export is because I think there is possibility that we may want to export resources which are not yet introduced. And that's one reason that we could use, we introduce a raw resource export. And similar to the other resources, we also have a status for exports, which essentially talks about what is the overall status of this exported resource. And for that, we have complied with like the status proposed, or rather how statuses are implemented using conditions. And so we introduce the resource export condition for that. And now the other side of the equation is the resource import. So similar to how services are imported into your local clusters via the service import resource, we also have another encapsulator, another resource which will be encapsulating those other resources which have been merged or created as a multi-cluster service, and or in this case service import, and then encapsulated in as part of the resource import spec, and then push to the clusters, member clusters, which are going to be reading from that imported, or which would be importing this particular resource. So similarly, this is cluster IDs, which would basically specify which are the member clusters to which this resource must be imported to. And if not specified, we will import them to all member clusters. And then some of those resources, some of those field names are pretty self-explanatory. And then again, this is what is a different type of resource. For service import, you will have this field set, and similarly for endpoints, external entity, and then for the raw resource import. And similar to the export conditions or status, we also have a status for the resource imports. And yeah, this is how the overall pipeline would look like. So you can see that there are several components now. Some of those can be performed by a single controller, but on a high level, you have these member clusters and these light blue boxes, and then the leader cluster is a slightly darker blue box, wherein the leader cluster components reside. As we know that the leader cluster is responsible to merge those services or create those multi-cluster services or other resources that would be exported in the future. That's the job of the leader cluster, and then it will be responsible to push those resources to the different member clusters, which would be importing those resources. So, and then in the member clusters, you will have users creating services, and then they will create a service export, mark that service to be exported. And that will be then monitored by an exporter controller, which will essentially encapsulate it into a resource export resource. and then push it to something called a common area, which was sort of an abstraction for where these resources are pushed to. The leader cluster would listen to this or would monitor the resource export events, and that controller will then, we would perhaps in the future have some filters applied on top of this controller, wherein certain criterias would determine whether these resources should be further moved into the pipeline or not. And those filter criteria can be added on later. Today we don't have them yet, but we would want to keep like the criteria to filter also part of the pipeline so that it can be extended in the future. Once it's deemed fit to be moved on, the exporter controller, the multi-cluster manager component within the leader cluster will then get all those related same services from the resource export resources. It will decapsulate it, it will extract those resources, and then as Lan mentioned in the beginning, that a multi-cluster service is basically backed by different services from different clusters. So that's the job of the multi-cluster manager, to create this multi-cluster service. And then it will push it down to a controller, which would then encapsulate this into a resource import resource and the different service import resource as well. And then it will push it back to the common area from wherein the member clusters would be listening on and monitoring these resource import resources. And then it will be extracting the multi-cluster service, let's say, from those encapsulated resource import resources. And then it will actually go ahead and create the service locally for the consumption. So now the member cluster gets a multi-cluster service, which is, as Lan previously mentioned, that it's a regular Kubernetes service. So the importer will then create the service locally in the member cluster, and now any workload in your local member cluster will be able to consume this multi-cluster service. And then, as Lan previously already mentioned, that it will be then it will then be pushed to a remote cluster service, which will be actually serving that particular service. So that's basically how the exchange pipeline would work, and how the member clusters and leader clusters interact, and how different components interact with each other. This is just like a sample workflow wherein we talk about how a Kubernetes service, say foo ns, Kubernetes service foo in the namespace ns in cluster 1, and the same service in cluster 2 present in the same namespace, how they would be merged into a single multi-cluster service called MultiCluster foo. So administrator will create these exports in the foo namespace, foo in each namespace in the clusters, and then the exporters will catch that, will watch on that, and then it will export that as a resource export to the leader cluster, and the leader cluster will now get notification of these two services being exported. Now it figures out that it's part of the same service. It will create a multi-cluster service called MultiCluster foo, and it will associate its endpoints, and then it will encapsulate it into a resource import resource, which will then be pushed down to the member clusters, which are actually listening on to this leader cluster for these resources. And then it will extract that MultiCluster foo resource service and the endpoints, and then will create them locally. And then your workload should be able to access this multi-cluster service. If something fails in between, the status of the resource would be updated to whatever the error that was encountered as part of this. So this is basically how the information would exchange would work. And similar to this, other resources can also be exchanged in a similar fashion by introducing these resource import and export CRDs. And so that's pretty much like the overview of the different CRDs that we plan to introduce, and kind of like the how the multi-cluster set workflow would take place. We have a few items that initially we mentioned that there are some items as part of use cases that we would also want to tackle, and those are something that we will focus on once we have the basics in. So one of them was the stretched Antrea native policies, wherein we would want to allow workloads from one cluster to securely connect to workloads in other clusters, and then make sure that they don't unintentionally access other workloads. So we have a few proposals for the stretched Antrea native policies. So our idea is to first start working on the implementation of the above said design, and then parallelly continue to nail down what design approach should we use to accomplish the stretched Antrea native policy. And this table kind of like summarizes some of that the three approaches that we feel we have to as part of the design, and it gives some pros and cons about it. So we can also get some feedback based on that, but we will continue to evolve this discussion. In addition to that, there's also, I'll briefly talk about the data plane design also, but Lan can talk more on this if there is interest. Essentially, we also want to make sure that along with the multi-cluster design, we would also want to provide a change in the data plane such that pods in one cluster can communicate to pods in other clusters by changing some of the aspects in the data plane, by introducing either some IPsec tunneling between multiple clusters, introducing gateways, or it could also be a full mesh mode wherein every pod is able to connect to every other pod. And all nodes are reachable with each other. And perhaps Lan, maybe you want to add some more on the data plane side of this.
Yeah, not much. Just like to mention that the current design, there's an assumption that either the pod IP or the cluster IP can be accessed outside. That's, I think, a limitation to some customers. So in our roadmap, we like to, in the future, to do some change on the data plane, so we can, remove the limitation, so the customer can use the remote or the MultiClass service without exposing their service through the external IP or through the pod external IP. Like that. Yeah, but I think still on the discussion, and we will focus on the current design first. Yeah.
Yeah, and big thanks to Lan for working on this, and also Akshay and his team, who also contributed vastly on this design. So if you guys have any other question, I see that Akshay is also on the call. So if you also have something to add.
Abhishek, I think you covered everything.
Yes, so if there's nothing else, then maybe I'll stop sharing and then you can continue.
Thanks, Abhishek and Lan. That was extremely informative. I have to say that the whole proposal needs some digesting to do, at least for people coming the first time into contact with it. It seems like a fairly big work. So is the roadmap, I believe the roadmap will be spread across multiple Antrea releases ideally. Is that correct?
Yes, correct. So we actually have created a feature branch on which we plan to start working. And we have actually some sketch work PRs already up there. And what we plan to do is that at least what we have so far discussed in detail. The idea is that we continue with the 1.4 timelines as target, but we do believe that 1.5 seems a bit more practical, but at least we want to target 1.4. And then moving forward, we probably continue for the items on the roadmap. We still haven't discussed which releases, but that would be certainly after 1.5.
Okay, thanks, Abhishek. All right, so we still have a few minutes left in the meeting. Is there any question from the community regarding this proposal, the implementation, data plane design? Please, go ahead and ask all the questions you may have to Abhishek and Lan.
Actually, I have a question for stress the policy. I was just thinking, do you see any requirements we need to in the leader cluster? We need to know about the member cluster objects for user to define the policy and to see how policy are realized. Or you think probably it's not needed? Yeah, go ahead.
Yes, so I think if we want to apply policies, based on pod workloads, so maybe there is some need to be able to fetch that inventory, or to be able to see what kind of pods exist, what kind of services exist. So maybe there is that requirement, which will help a user, because our eventual goal is to create these policies in the leader cluster. So if you don't have the world view of your multi-cluster set and the different services, then in that case, it might be harder to write such rules from the reader cluster. And in that case, you'll have to write policies in the member cluster, which might not be desirable. I don't know if Akshay or others have any other thoughts to this.
The problem that if we do that, does that mean we have to create one object for every pod and the namespace in the member cluster, in the leader cluster?
One object in what sense? You mean?
If you think the user should be able to know what the endpoints in the member cluster from leader cluster, then I mean we need to create one resource, one CRD, whatever, for every pod and every namespace in the member cluster inside the leader cluster.
I don't think so. I think the idea probably would be to create that policy, but the policy should probably be transferred or
okay,
to the member clusters rather than the other way around.
So I mean whoever create the policy should know about what the workloads in the member cluster.
Yeah,
maybe from the member cluster.
Yeah, that's why I was thinking maybe like an inventory kind of thing would help to understand what are the different workloads available, so that they can write this policy and then push it to those member clusters, and then it will be actually we don't need to actually create those objects in the leader cluster. I don't think that might scale.
And how about the realization and still have some troubleshooting API like to check the effective members of the group? This kind of thing. Do we want to retrieve state back from member cluster to leader cluster, or you need to go to every member cluster to debug?
For the policy side?
Yes.
It might be, I think for troubleshooting, I think locally might make more sense. So depending on which approach we end up choosing. So let's say if we are doing the exporting the computed group members, then we actually already have the computed list on where the actual policy will be realized. So in this case, on the member cluster side, you already know which pods you're applying to and what to from exported group members are already part of the. So maybe it might be easier to debug on the member cluster side. But here again, I mean, if there is any changes in the computed group members and which has not yet reached, or those changes in the computed group members have not been reflected correctly in the remote cluster, then in that case, we might not be getting accurate information. So I guess it needs to be like correlated with what is the status of this export, whether it's whether those exporting clusters are still reachable or not. So there are, I think, multiple ways in which this may there might be some misinformation.
How about the state like realization status and the stats? Do you want to connect and aggregate in the leader cluster?
For the stats, I think I know that there was at least folks who are working on the flow exporter side. I do believe that they were also mentioning that this is something that can be put on the roadmap to be able to unify the stats across clusters. But I haven't had any detailed discussions on how we would go about and approach this.
And the realization.
But are you talking about the network policy status?
Yes.
Just those. Okay. Let me think.
And then why is the realization and the other is the stats?
One is realization and the other, yeah.
Yep.
For realization, I think we continue to do it on the member cluster because so for example, if again we think about the first approach, the policy will be realized in, let's say, in your local cluster. And for the local cluster, you are going to your span is going to be your cluster nodes and the pods in your workloads in your own cluster. So today what we have will work. As in we already have the status, realization status for the local single cluster network policy. And the exported group members are going to be like IP blocks perhaps. So it won't reflect whether this I think at least from the realization perspective, at least we can report the status saying that in my local cluster it was successfully realized or not.
Okay.
Does that make sense?
Yes. So you still say in the leader cluster we want to aggregate, right? At least in the leader cluster we can say the project is realized by which cluster.
So in the leader cluster, perhaps we can have some component which aggregates the different policies, at least the ones which are spanning across, and then perhaps we can have. I mean, I have not jotted down that particular item, but that's something I think should be possible if you just it's similar to how we do aggregation of policy information from different nodes to the single Antrea controller. Now this would be aggregating from different controllers to a single leader cluster controller.
Okay.
But that's something that is currently not added in the items, but definitely I'll make a note of the aggregation part here.
Okay. In general, I just think maybe it's useful if we can aggregate all the state from the member cluster, like realization stats and even group members, if we use different way to implement the policy in the group.
Mm-hmm. Yeah, making a note of your suggestion. Got it. Yeah, any more questions, or is it just okay?
Yeah, I was asking the same. We'll probably wait like a few more seconds for any additional questions.
If there are no more questions on the multi-cluster side of things, I actually just wanted to make a quick update on the upstream network policy work. I think it's been quite a while that I haven't given a brief update. We are continuing on the cluster network policy effort. And last week, I had a one-on-one with Tim Hawkin, and we, I think, have progressed well enough on to at least him understanding the proposals that we have. And he has a couple of inputs to that, and I have incorporated that in our proposal. In addition to the CNP work that we are doing, there is also an effort to do network policy status in upstream. Now, this is something that we have done in Antrea native policies, but it's still not part of the Kubernetes network policies. And I think the motivation behind the introducing the status is that recently the endport feature was merged in upstream Kubernetes and for network policies. And as part of its GA requirement, there was requirement that at least 4 CNIs supported. Antrea is one of the CNIs which supported, but there is, I think, only 3 CNIs so far which are supporting it, and it's not yet gotten like the 4th CNI. Now, so I think the SIG network community feels that we should have a way, because now this is part of like beta network policy. Sorry, this is part of a network policy resource as beta, this field. And some CNIs would support, some won't. I think there was a need for people to have this information be exposed in the form of status. So there is some work there. I know one guy from VMware who, Ricardo, is helping out, but I think he needs more help. And if anyone in the Antrea community wants to work on this particular KEP, feel free to get in touch with me and I can put you in touch with Ricardo. Similarly, there's also a parallel effort to work on the V2 aspect of network policies. And I think some folks from Juniper and Red Hat are trying to work on this use case, or rather this new V2 resource for network policies. But again, if there's anyone in the community who wants to work on anything network policy related, feel free to ping me. That's it.
Thanks, Abhishek. All right. Anything else that, as you already like 5 minutes over time, unfortunately, is there any final topic that you like to bring up for discussion today? I'll wait a few seconds. Otherwise, we'll call this meeting off, and that'll be it. All right, so I think that it might be all for today. I would like to thank everyone for joining, and most importantly, many thanks to Abhishek and Lana for this very extensive presentation about multi-cluster support. If you have any additional feedback, of course, the discussion does not end here. You can provide your feedback on the GitHub issue, or even provide your comments on the design document that has been presented today by Abhishek and Lan. So thanks again for presenting this, and thanks everyone for attending. The only thing left for me to do is to wish everyone a good evening, a good morning, or a good afternoon. Thanks again for joining, and talk to you again in 2 weeks' time.
Thank you. Bye-bye.